All right, so we are going to start our new unit and we're heading into trig. So there are just a couple things that just sort of housekeeping items that we're going to need as we go through all of our trig lessons. So that's what we're going to hit first before we get into, we're going to review arc length and sector area. We're going to review our basic trig functions and how we solve triangles for missing pieces, just like we did in geometry, angles of elevation. Okay, so the majority of this unit is review of things that we've done before with a little bit of extra pre-cal stuff before we head into the actual trig functions and dealing with that. So things that are different from geometry when we're dealing with trig, okay? An angle on the coordinate plane is considered to be in standard form when the vertex is at the origin, the vertex of the angle is at the origin, and one ray, one side of the angle, lays on the positive x-axis, which means it's going to be this side pointing to the right. Okay, so every single angle that's considered to be in standard form is going to start here. So one edge of the angle is at the origin and along the x-axis. Okay, and then the other side going the other way, this ray here is called, well, sorry, let me rephrase, start over. This original side is called the initial ray. That's our starting side of that angle, right? The initial part. Okay, the other ray on the other side is called the terminal. Terminal is like when you terminate something, that's the ending of it. So this is our terminal ray. Okay, so starts with the initial ray along the x-axis, and then this other angle opens, or the other side opens up anywhere, and it could be in the first quadrant, second quadrant, okay, whatever. All right, so counterclockwise rotations are going back this way to the left. They are going to result in angles that are positive. Okay, if we have an angle that starts here on the x-axis and the terminal ray is down here along the bottom or below the x-axis, this is going to be considered a clockwise motion because it starts here at this initial ray and it's going to open up back this direction to the left. That is going to be a negative angle or a negative measure. Okay, so in geometry, we only ever talked about positive angles. Okay, so now in pre-cal, we could have negative angles as well, and the only difference is whether it's considered counterclockwise or clockwise. Okay, the most common unit of measure for angles is obviously in degrees. Okay, and you're going to see the degree symbol. 1 degree is equivalent to 1/360th of a full rotation. If you rotated all the way around from your initial ray all the way around and came back to where you started, that would be 360 degrees, right? So 1 degree is one of those 360 degrees, okay? So this is our starting initial ray. We're starting at 0, okay? If we come up here, straight up, that's 90 degrees. Okay, all of this stuff over here is considered first quadrant, right? If we go past 90 degrees, this is up to 180 degrees. Over here is our second quadrant. So if I have a terminal ray over here in the second quadrant, I know that the angle is going to be somewhere between 90 and 180, right? If it comes back down here, this is the third quadrant. This is going to be a negative angle. It's going to start here and it's going to come back this way. Right? And then this is the fourth quadrant, our last bit from 270 to 360. Okay, so sometimes there's more than one way or more than one measure that we could use to name our angle. Because sometimes like we can go all the way around the circle and come back again a second time, right? Or we could go this direction to start, go counterclockwise to start, or we could come clockwise, and those would be at the same location, right? That terminal ray is sitting at the same spot, but we have 2 different names for that angle or 2 different degrees for it, okay? All right, so we're going to start with sketching. sketch an angle in standard form with the given measure. So if it's in standard form, we have to start with this initial ray along the x-axis starting at the origin, and we're only going to go up 65 degrees. So from here all the way up to here is 90. Halfway would be 45, so we need a little bit more than 45, so maybe sort of like this, okay? And then we'll just put a little arrow right here to show that is opening from the initial ray to the terminal ray so that we don't think we're going around back this way, right? And a lot of times in pre-cal, we use the symbol theta to represent our angle measure in there, okay? So it's a little circle with a line through it, okay? 320 degrees. It is positive, so we're going to start here with our initial ray on the x-axis, and we're going to start heading this way, 90 degrees. Keep going, another quadrant, that's 180. Keep going, another quadrant, this is going to be 270, okay? So I don't want to go all the way to 360, so maybe sort of like in here somewhere. I don't know, it doesn't have to be perfect, okay? But this is showing that our angle is coming around this way. Okay, if we wanted this little bit right in here, that would be a negative angle. It would be negative 40, right? 360 take away 320 is 40, so that would be a negative 40 degree angle if we wanted to go back that way. Okay, all right, 415. Okay, so what I noticed right off the bat is 415 is more than one full rotation all the way around. So how much more than one full rotation all the way around? So if I subtract off a full circle of 360, that's going to leave us with 55 degrees. Okay, so the way to show this is we're going to start here with our our initial ray, and we're going to go all the way around once. So I'm going to draw a full circle. Okay, I don't want to come back to that, but because I'm going to keep going. I'm going to keep going 55 more degrees, so maybe like that, right? So this sort of spiral here shows that we're going to go all the way around once and then a little bit more. Okay, and it's still positive, so we're still going in the counterclockwise method. Okay, then we switch to negatives. Okay, so we still start at the same spot, but this time we're going to go counterclockwise, and I'm going to come down this way. So this is 90 degrees, and then I need a bit more, not all the way to 180, so maybe in here somewhere would be 140, right? It doesn't have to be perfect, but it needs to obviously not be at 90 and obviously not at 180. All right, everybody okay with that? Cool. If you're not, come back and see me tomorrow or ask a friend. Okay. All right, the next thing is radians. So sometimes our angles are measured in degrees, okay? Sometimes they are measured in radians. A radian is a unit of angle measure based on the arc length. So it compares the size of the angle to the length of the arc going around the outside, which is sort of like part of the circumference of our circle, right? Okay, so 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the arc. Okay, so 1 radian is when this radius here from the center to the edge of our circle is the same as this length when we wrap that sort of around the edge of our circle. That's considered to be 1 radian. Okay, so remember, all the way around a circle, circumference is all the way around the circle. That is considered 2 pi r is our formula for all the way around. Okay, so if we're talking about 360 degrees, we're going to write that as 2 pi r, or just 2 pi, I guess. 360 is 2 pi, and 180 is half of that, which would just be pi. Okay, r is going to come later. We'll deal with, that's just going to be our label.
Teachers, okay. Pardon this interruption. Teachers, do not send students to the Kona Ice truck. They can do that during lunch.
Kona Ice.
Time, so if they missed it during their first lunch, that's too bad.
Get your booty in class,
lunch,
yo.
They need to wait until second lunch. Do not send students outside. Thank you.
All right. So here is the formula for converting between degrees to radians or radians to degrees. All right, so if you're starting in degrees and you want to change your answer to radians, okay, we want to put pi into our answer. So it's going to go up here on top, and this degree is going to cancel with this 180 degrees down here, okay, and we're going to lose that label. So we're going to take whatever we have times pi divided by 180. So for example, if I had 360 degrees and I wanted to change that into radians, I already told you it was 2 pi, right? So we're just going to check that. So we're going to take this 360 and we're going to multiply. We want it to be in radians, so we're going to put pi on top, and we're going to have the 180 degrees on the bottom. So these degree symbols are going to cross out. They're going to cancel, and we're going to be left with pi in our answer, okay? And then 360 divided by 180 leaves us with 2 pi, right? We'll do some more examples of that here in a minute. So if you're changing, starting with degrees, and you want to put it into radians, you want pi on the top and the 180 on the bottom, okay? If we go the other direction and we're starting with radians and we want to change it into degrees, let's start with our radians of 2 pi. This is all the way around the circle. So to change 2 pi into radians, I already have pi in my answer, so I want to get rid of it, which means I need pi down here in the denominator so that those cancel. And we're going to put the 180 degrees on the top. So what's going to happen this time is the pi's will cancel out. That's on top, that's on the bottom. And now I have 2 times 180 degrees, which makes 360 degrees. Okay? So the question is, it's not so much that you're memorizing the formula. You need to memorize it's pi with 180, right? It's either pi over 180 or 180 over pi. You need to know that part, okay? Then, do you want to put pi into your answer or do you want to take it out? That's really the question that you need to ask yourself, okay? So for example, converting degrees to radians. Let's do a couple of these. I do not have a calculator, so let me get a calculator real quick. All right, so if we start with, whoa, my chair just moved. Okay, if we start with, let's see, which one do you want to do? Let's do 330. Okay, so if we start with 330 degrees, I want to convert this angle into radians. So I want to put pi into our answer. So we're going to multiply this by pi over 180 degrees. Okay, which means that these degree signs are going to cancel out, and we're going to have 330 times pi divided by 180. Now, I don't want to type pi into my calculator because it's going to change it to 3.14, and I just want pi to be in the answer. So what I need to do on my calculator is this 330 divided by 180. This is division, right? So 330 divided by 180 gives me 11 over 6. So this answer is going to be 11 pi over 6. Pi goes in the numerator. Okay, all right, let's do another one. So this is negative 45 degrees. We want to change it to radians. So I want to get it out of the degrees and put pi into the answer. So pi goes on top, 180 degrees goes on bottom. So the degrees will cancel out. And we're going to have negative 45. If you want to write it like this, you're going to have negative 45 pi divided by 180. Well, we just need to reduce this if possible. So that's the part that's going to go into my calculator. Negative 45 over 180 changes to negative 1/4. And I got to make sure the pi goes there with that 1. So that's going to be a negative pi, or a negative 1 pi divided by 4. You okay with that? Okay, so if we're going to go the other direction, we're going to convert these angle measures to degrees. So they already have pi in them. Let's take this one. 11 pi over 9. So if I want to change it to degrees, I need to change degrees. That was a hard word. Get rid of the pi. So when I multiply I want pi to be on the bottom, so those will cancel out, and the 180 degrees will be on top. So now these pi's are going to go away. And we're going to have 11, straight across the top, 11 times 180 divided by, the only thing down there on the bottom is 9. And that just goes into your calculator. 11 times 180 divide by 9. 220 degrees. Okay. All right, let's do one more. What about, let's do this one. How about negative pi over 6? It's already in radians. We're going to change it to degrees. So we want to get rid of the pi. So we're going to multiply it by 180 over pi. So the pi's are going to cross out. Bloop, bloop. And across the top, we're going to have this negative. I would put it with the numerator. Negative 1 times 180, or negative and the 180. You don't have to put both of them. And down here in the bottom, we have the 6. So negative 180 divided by 6 is negative 30 degrees. Okay, and you got to make sure that you have the degree symbol on your final answer so that we know that we put it back into degree. Okay. All right. All right, the next thing is sometimes when we're dealing with angles that could be both positive or negative, sometimes it's easier to work the problem with one or the other. Okay, so it's nice to be able to switch back and forth. Okay, like negative 90 degrees. If I went negative 90 degrees, that would be right here. Yeah, but if I went the other way, that would be positive 90, 180, positive 270. So positive 270 degrees and negative 90 are considered coterminal angles because that second part of my angle, right? The initial ray stays in the same spot, but my terminal angle or my terminal ray is going to be in the same spot for both of those particular angles. Okay, so sort of like they're congruent, right? They're not necessarily the same size because one's much bigger, right? 270 is much bigger. It goes through 3 quadrants versus the negative 90. But as far as where the other side of that angle is located, those are in the same spot. Okay, so sometimes it will be helpful to be able to know where that other side of our angle is. Okay, so we have this switching sort of back and forth between angle measures. Okay, so it says angles are in standard position. They have the same terminal side. They are considered coterminal angles. Okay, determine whether the two angles are coterminal. Okay, so for example, 270 and negative 90 are the same. Okay, in their example, they did positive 90, which would be this angle right here, positive 90, and then they did negative 270, which is all of the rest of this. Okay, so what you should notice is that the two angles together make a full circle, right? Two angles, the negative part and the positive part, if you sort of disregard the negatives, those two should add up to 360, right? Okay, so if I started with 305 and I took away 360, because I want to see if this is the same, right? So if I subtract and I go one full rotation back around my circle, negative 360 degrees, is it going to put me at negative 55? 305 take away 360 is negative 55 degrees. And see how those are the same? So if those are the same, then yes, these are coterminal. You're not going to have to write that down later, but I just want to do that for our notes. It's just yes or no. Yes, these are coterminal if you get the same thing. Okay? Okay? If we started with the negative, if I'm already at the negative number and I want to see if this positive matches it, instead of subtracting, we could add on the 360, right, to see where that would be in the positive. So negative 170 plus 360, negative 170 plus 360 is 190. Is that the same as 30? That is not the same as 30. So no, these are not the same. Okay. If they are in radians, okay, what is one full rotation of our circle in radians? 360 degrees is the same as 2 pi. So instead of adding or subtracting 360, when we're dealing with radians, we are going to add or subtract 2 pi. So let's start with our positive one here, okay? And we're going to go to this negative value, okay? So if I start with pi over 4, we're going to subtract 2 pi, right? Subtract 2 pi. I don't know why I put that there. Pretend that's not there, okay? So if I want to do this on my calculator, I'm not going to type in the pi. I just really want to know what these numbers are around that. So in front of this pi is a 1. So if I disregard the pi and disregard this pi, and I just type 1 over 4 take away 2 in my calculator, that's how I can get around that. We don't want to type pi in the calculator because it's going to be ugly and it's going to do a whole bunch of long decimals and stuff like that. So I want 1/4 take away 2, and I want to see if that makes negative 9 over 4. That makes negative 7 over 4. So then I can put pi back on it to get it back into radians. Is that the same? Are these the same? No. So these are not coterminal angles. Okay, let's try this last one. Do you want to add or subtract? Let's add, because you could really go either way. Let's start with the negative. Okay, I would pick one and do the same thing every time, but it's up to you. Okay, so if I start with the negative, I'm going towards positive. I'm going to add 1 rotation around the circle, which is 2 pi. So in my calculator, I'm going to type negative 5 over 2 plus 2. Negative 5 over 2 plus 2. Okay, look what happens. We are still at negative. We're not even in the positive yet. So we need to go around the circle one more time, or maybe more than one time, so that we get this to be a positive value. So we're going to add again. We're going to go around the circle more than one time. So if I take that negative 1/2 and I add another 2, I get 3 over 2. Is that the same as what we started with? 3 pi over 2? Yes, those are the same. Okay, so sometimes you have more than one rotation and you have to like repeat the process over again until you get either into the positives or get into the negatives, depending on which way you're starting. Okay. All right, the next section or the next thing, it's just going to ask us to give 2 coterminal angles. So we're essentially listing some things that are congruent to this, okay? But we want one to be positive and we want one to be negative, okay? So the easiest way to do this is just to add 360. So we're going to take this number and we're going to add 360. And we're going to get a number. And then we're going to take that same number and we're going to subtract 360. Since it's in degrees, right? Plus 360 or minus 360 is all the way at once around the circle. So 150 plus 360 is 510. So that's one of my answers. And 150 take away 360 is negative 210. And make sure it has your degree symbol on it. And these are your 2 answers. One's positive and one's negative. Okay. And again, sometimes on this, if you start with a really big angle, you might have to go around more than once so that you have one positive and one negative. Okay. So same process every time. Plus 360 minus 360. Okay. So I'm just going to write that out. Plus 360. This one is a negative 25. And we're going to take away 360, right? We're going to go once forward around the circle and one backwards around the circle. And then whatever we get, those are our 2 answers. Okay, I'm not going to do that one. Let's pick one down here with our radians. So instead of adding 360, what do we add for radians? 2 pi? Yep. So we're going to plus 2 pi, and then we're going to do the same thing. This one says negative 11 pi over 18, and we're going to subtract the 2 pi. So one is plus, one is minus. Okay. Do not type pi in your calculator for this, right? We're going to do everything except the pi. So we're combining our like terms. Imagine those were like x's, right? Negative 11 over 18x plus 2 over x. You just add the numbers and you tag x onto the bottom or to the back. Okay, so we're going to do negative 11 over 18. Oops, I did minus. Just kidding. Negative 11 over 18 plus 2 is 25 pi over 18. And then negative 11 over 18 take away 2 is negative 47 pi. Put pi back into your answer over 18. Okay, don't type pi in your calculator, but tag it back on. Okay. All right, so again, what we've looked at so far is we sketched an angle, deciding whether it's positive or negative, which way is the terminal ray going to be located, where's that going to be. We talked about switching between radians and degrees. We did some practice with that, changing radians to degrees. We talked about coterminal angles, telling whether the angles given are the same, whether they're equivalent or congruent. Okay, and then finding some angles that are congruent. Okay, all right, the last thing we are going to do a little bit on this next page. We're not going to do all of them because there are a billion problems. Okay, but this is the other thing that we are going to see when we get into pre-cal. Okay, sometimes our answers, or not our answers, sometimes our angles will be given in degrees, minutes, and seconds. This is a way to be more specific. Okay, like a 90-degree angle is not always exactly 90 degrees. Well, I mean, if it's a right angle, it's exactly 90. But sometimes it could be like 90.015 or something like that, right? Or 90.8 or 90.635 or whatever, right? So when we get more specific, we talk about our angles being in degrees, minutes, and seconds, okay? Now, the problem is you can't type this into your calculator. So when we see this, the most often we're going to take our answer from this, which is what they're going to give us from their measurement, and we have to change it into a decimal so that we can type it into our calculator, okay? But we do need to be able to go either direction from that, okay? So what we know is that 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds. Okay, 1 degree of our circle is 60 minutes, and 1 minute is worth 60 seconds. Okay, so if we wanted to go from here, from 1 degree all the way over to here to seconds, we would need to multiply these together, right? If we have 1 degree and we want it in seconds, we're going to multiply 60 times 60 to get 3,600 seconds. So 1 degree has 3,600 seconds in it. Okay, and we're not talking about like length of time. We're talking about like how far the hand on the clock moves, right? When it goes 1 minute, the second's hand goes all the way around, right? When we move 1 degree, that's like a whole 60 minutes. Great. Okay, yeah. All right, so here are symbols: degree, minutes, seconds, circle, 1 apostrophe, 2 apostrophe. All right, so the method for changing between these is relatively simple. You're just going to have to follow along as you go, okay? So if I want to change 31.875 degrees to degree, minute, seconds. You're going to see this as DMS, degree, minute, seconds. Okay? The 31 is going to stay there. Like, I already know this has 31 degrees. Like, that part stays. I need to get the minutes and the second part. Okay? So what we're going to do is we're going to take that decimal, whatever is there, 0.875, and we're going to multiply it by 60. Times 60. That's going to change it into minutes for us. Okay? So when we do 0.875 times 60, we get 52.5. Now, if that was a whole number, I would have all minutes and no seconds. Because you don't have to have all of them, right? Okay. But since there's a decimal, okay, this 52 becomes our minutes, 52 minutes. And then we're going to take this decimal that's left, the 0.5, and we're going to multiply that by 60 again to change it into our 60 seconds. So 0.5 times 60 is 30. Okay? If this were to have a decimal, if there's still a decimal here when you're all done with these two steps, you are going to round this to a whole number. Okay? Because it's like super tiny, small, it's sort of inconsequential. Okay? But here we have a whole number, so this is 30 minutes. Okay? All right, so let's try number 3, 89.915 degrees. All right, so I'm going to put my answer down here. I'm going to start with the 89 degrees, like that part stays there, right? Then I'm going to take the 0.915, and what are we going to do with that? We're going to multiply it by 60. 0.915 times 60 makes 54.9. So from here, we're going to take the 54, and that's going to be the next part of our answer. That's our minutes. And then the last bit, the 0.9, we got to do that, multiply by 60 one more time. And 0.9 times 60 is 54. So we have 54 more seconds on that. Okay. All right, let's do one more. Let's do number 6, 273.771. To degrees. It's already in degrees. We want to change it to degrees, minutes, and seconds. So I got to change this 0.771. So 273 is going to stay as our degrees. Then we're going to take the 0.771 times it by 60. 0.771 times 60 makes 46.26. So the 46 comes down as the next part of my answer, minutes. And then we're going to take the 0.26 and we're going to multiply that by 60 again. 0.26 times 60. Oops, that is not right. And we get 15.6. Okay, when this last answer is a decimal, we're going to round this to the whole number. So is this going to be closer to 15 seconds or 16 seconds? 15.6 is closer to 16 than it is to 15. Make sense? Okay. Every now and then it will ask for your final answer to come out of degrees and to be written as degree, minute, seconds. So that's when you would use this. More than likely, you're going to do this stuff over here on the back. We're going to go the other direction. Okay, so it's like, hey, here's a triangle. This angle was measured as degrees, minutes, and seconds. Figure some things out about the triangle. Well, I can't type this into my calculator like this, so I have to change this into a decimal before we can put it into our calculator. Okay, so in order to do that, we're going to take, again, the 73 stays there, right? Like the 73 degrees is the first part. That's going to go in front, no worries. Okay, 73 stays there. Then I'm going to take the 9, which is our minutes, and we're going to divide it by 60. 9 divided by 60, and I want it as a decimal, so I'm just going to put a decimal at the end of the 60, so it automatically changes that for me. 0.15. If it doesn't automatically change, Control Enter, change it to a decimal. Okay, I'm going to hold on to that. I'm not quite done yet. Okay, and at the same time, I'm going to take the 50 and divide it by 60 as well. 50 divided by 60 is 0.833. Whoa, just kidding, not by 60, my bad. How many, we want to change this into degrees. So how many degrees, or how many seconds in these, I'm saying the wrong thing. 1 degree is how many seconds? 3,600. Y'all, it's my first time doing this, y'all. It's been a whole year, okay? So we divide the minutes by 60, and we divide the seconds by 3,600. So pretend I didn't do that last thing. We're going to divide by 3,600, and we get 0.0139. Okay, we'll round. We don't need to write all those decimals, right? Okay, now here's the last step. We're going to take these two answers, and we're just going to add them together. Okay, so 0.15 plus 0.0139. I'm going to add those together, and I get 1639. So this is 73 degrees and 1639 ten thousandths or whatever it might be. Okay, and we are going to write these to 4 decimal places. Okay, for accuracy. Okay, so let's do one last problem. We're looking good for time. Okay, let's see. How about 13? 310 degrees, 28 minutes, and 20 seconds. So the 310 stays there, and now I need to change the rest of that to a decimal. So the first number, the 28, is going to be divided by what number? 60. And then the 20 is going to be divided by what number? We're not going to say 60 because that was wrong. We're going to divide it by 3,600. So I'm going to type both of those into my calculator. 28 divided by 60. Again, I'm going to put a decimal in there because these don't have decimals. They would automatically revert to a fraction if I don't put a decimal there. So 0.4667. And 20 divided by 3600 becomes 0.0056. And then we're going to add those together. So it might be faster to add like by hand. That's 13, 11, 12, 6, 7, and a 4. So 0.4723. And then we just put our degree sign on it. Okay. Last thing here is if we don't have the seconds, then you just don't worry about obviously dividing that part. Like you're just going to do the one division. Okay. Divide the numbers by 60 or by 360. Add them together. Okay. Round. Use your calculator. Do the things. Okay. All right. So your assignment is homework 11. And we are going to, let's do odds. Let's do odds. Okay, homework 11, odds. 1, 3, 5, 7, 9, 11, 13, 15, 17. Okay, and then come down this left column. Okay, all right. Grab your assignment, get on it, come see me if you have questions, okay? Love you, bye.